Welcome to our presentation. As we start, we're going to put in our file to be processed because it takes a very long time. So image processing and edge detection is what our presentation is over. We're a team 20 and our members are myself, Justice Rowe, Caitlin Doherty, Kenneth Prather, and Michaela Peterson Jensen. So our image processing and engineering, we each did some research on how it's applicable in our fields. So for me, electrical engineers are using it in agriculture to help identify conditions in large fields.
Image processing and computer engineering helps with computer vision work and other applications such as driverless vehicles.
In the biomedical field of engineering, image processing can help identify characteristics of tumors or organs.
Image processing in civil engineering can create a 3D design from a 2D image by detecting edges and the other characteristics of a 2D design.
Cool. So we hope you enjoy our presentation over our code. So while this continues to load, I'll briefly explain all of our code and how it's modular. So we have our main function, which calls in all the libraries we needed, and also calls in all our files, which have our user-defined functions. As you'll see when we go through our second image, we'll go more in depth to how this works, but it takes in our image and takes the input from the user and puts it into each function and takes the output from each of those functions and puts that back into the next function and continues to run through each function until the image is processed. So our first function, which Michaela worked on this one, is our grayscaling function, which pretty much just takes all the RGB values and sets them to this value that you guys gave us in class, and saves it, and then sends it on to the next function. And then we have a numpy function that does our blurring, which pretty much just takes every value in our image array and sets it equal to the average of all values surrounding it. And the more times you run this, the more blurry the image will get. So we found that running it 3 times was optimal for processing and for get a good quality blurred image. Our Gaussian function, this is our other blurring function that uses SciPy. We have this one also just because it produces a slightly better image and is more optimal. So we decided we would include both. We use this one in the actual processing because it's just more optimal, but we do have this one that just utilizes numpy. Our edge detection function, and I should say that I worked on this one and then Michaela worked on this one and I worked on this one as well. And this is our edge detection function that uses a horizontal and vertical filter that we learned about in class, and it applies it over every 3x3 set of values on our array. And then it averages our vertical and horizontal values together and then remaps them to a new image. And this is our edge detected image, which you can see just finished processing as I was speaking there. And that's what that looks like. And then our thresholding function, Kenny worked on this. It pretty much just asks the user for a thresholding variable. And if the value of any part of the array is less than the thresholding variable, it sets the brightness value to white. And then it sets all the other values to black. So if we go back to our main function, it now asks us for input a threshold variable. So as you can see, we have our processing of our image, and then it asks the user to input threshold variable. So 0.03, let's just try that. And we have it so the user can put in multiple variables if they would want to see what it looks like without having to completely rerun the code again. So let's say I like that thresholding variable, so I just type in no, and it saves our image. So now we're going to run in some of the usability of our program with our Purdue logo image. So Purdue logo.jpg is a smaller image that processes a lot faster. So we have it running and it asks, do you want to blur the image? So some images look better without being blurred. So we gave the user the option if they want to blur the image before it's processed or not. So in this case, we're going to blur our image. And as you can see what the image looks like at every step. So this is our normal image, our grayscaled image, our blurred images, and then finally our edge detected. And then we ask the user for input threshold variable and give them a specific range to start with. And then this allows them to continue to change the thresholding variable without having to rerun the whole program, which just makes it really easy for the user to find the optimal edge detected image without having to go through all that long processing over and over again. So let's say we stop at 0.7. We're like, yeah, oops, let's not do 0.7. Let's do 0.5. We say that looks good. We type in no, edge detection complete, image saved in the project folder. If we go to our project folder, we have our image at every step, our final image, our grayscaled image, our blurred images, and our edge detected images. So then for error detection, we have ask the user to input the picture file name. And if it's not, let's say, obviously that's not a file. So if they put that in, it gives them the error message, error, input must be an image file in project folder ending with PNG or JPEG. Please try again. So the user tries again until they type in a file that is in the folder that ends with JPEG or PNG. So we ask the user if they want to blur it. If they say no, or if they type in, if they just don't type in yes, it's going to go without the blurring. So in this case, we're blurring it. It's being processed. So then we get to input threshold variable. If the user puts in just something that's not a float, it says input threshold variable must be a number. Please run program again with accepted value. So then they have to run the program again. And then if they put in the correct value, that it's a float, so it just has to be a float. And finish there. Type in no, I don't want to try again. Everything is saved, and all their steps of image processing can be found in our project folder. So that's the basis of our code. We decided to split up each function into each basic processes, which is the grayscaling, the blurring, the edge enhancement, and then thresholding. Then we use the main function to bring all those together. So a user could use each individual function for if they just want to do one of the changes to the photo if they wanted. And yeah, that's why we decided to do that, do it that way. So thanks for watching. We hope you enjoyed our presentation.